Okay, we're going to start with a sine graph. So y equals sine of theta. In a sine function, the input is the angle. So that's on the x-axis. So let me kind of write that angle. Okay, so the input is the angle. The output is the sine value, which of course would be opposite over hypotenuse, but it is also the y-coordinate on the unit circle. So let's go back and just briefly look at the unit circle and see what some of the key points are. Okay. So if we go back to our unit circle and we look at the y value, we notice it starts out at 0, gets bigger and bigger till it goes up to 1. So we can see that sine goes from 0 to 1 to negative 1 to 0 and then back to 1, or I'm sorry, sine goes from 0 to 1 to 0 to negative 1 back to 0 again. Notice that as we move around the first quadrant, sine is getting bigger. The y-coordinate is getting bigger. As we move into the second quadrant, y is getting smaller but still positive. When we move into the third quadrant, y is negative but getting closer to negative 1. And then into the fourth quadrant, it's getting smaller numbers back closer to 0. So this is what we're going to see as we plot this on the graph. So there's a couple other things I want you to notice. So you might have your unit circle in front of you while you're working on this. So remember that square root of 2 over 2 is approximately 0.71. And remember that square root of 3 over 2 is approximately 0.86. Okay, so let's start with the biggies. At 0 degrees, the y-coordinate is 0 on the unit circle. And at 360, we're back to 0. And at 180, it's 0. Okay, so we're 0 all three places there. Where do we get up to the high point of 1? 90 degrees. 90 degrees, the y-coordinate is 1. What happens to the y-coordinate at 270? It gets down to negative 1. Now let's see what it's doing in between. As we move up from 0 to 90 in quadrant 1, we're seeing the y values get bigger. At 30 degrees, the y value is 0.5, or 1/2. At 45 degrees, notice that's in between the grid marks of 30 and 60. We're at square root of 2 over 2, which is 0.7. At 60 degrees, we're square root of 3 over 2, which is about 0.86, just a little under the 0.9 here. So this is what's happening in quadrant 1. In quadrant 2, we reverse the process and go back down to 0. So we can see that 120 is the same as 60, 135 is the same as 45, and 150 is the same as 30. So that's our points in quadrant 1. These are our points in quadrant 2. Then when we get to quadrant 3, we're going down into the negative values for y. 210 is negative 0.5. 225, which is halfway between 210 and 240, is negative 0.7. 240, negative 0.86. So this is be our quadrant 3. Then quadrant 4 has the same values but just going in reverse. So 300 is the same as 240. 315 the same as 225, and 330 is the same as 210. And so we have the graph that looks like this. It goes up, it goes down, make it look like a curve, sort of parabolish, but it's not a parabola. And then I should say parabola-ish, like that, yes. And then it goes back up again. This is known as a sine curve. One way I help students remember this is sine is a snake. It starts up out of its little hole in the ground, it slithers around, and it goes back into its little hole in the ground. So if you can think of a snake, kind of a snake shape, that's the sine curve. Now what happens after 360? Okay, well, you've got a circle, right? You got your circle, you go around the circle all the way around to 360. What if you keep going? Well, if you go another 30 degrees, you're going to end up at 390. But 390 is exactly in the same place as 30, so at 390 you're going to be back to where you were at 30 again. So, and if you keep going around, you're just going to repeat the same y values you had before. So this whole thing is just going to repeat itself. It's going to go up and down. There's one circuit. Up and down again. There's another circuit. And it's just going to keep going. If I go backwards, okay, so let's think of coterminal angles. If I go backwards to negative 90, well, negative 90 is the same as 270. So at negative 90, I'm going to be back at the same place I was at 270, right here. If I go back to negative 180, that's the same as positive 180, so sine will be 0. If I go all the way around to negative 270, so if I keep going to negative 270, that's the same as positive 90. At positive 90, sine is 1. So we're going to have the same sine value. And then back down to 0 at negative 360. So this curve is going to continue. It'll continue forever in both directions, repeating itself every 360 degrees. I forgot to write quadrant 4 down here. This would be my quadrant 4 part. Now, what was I going to say? There was something important. I actually had to pause the video to figure it out. I just wanted you to label the key points. So the key points that help us to draw the curve are at 0 degrees, we start at 0. At 90 degrees, high of 1. At 180 degrees, we're back down to 0 for the sine value. At 270, we're at the very lowest point, negative 1. And at 360, back to 0. I gotta figure out a better place to label that. So at 360, we're back to 0. Okay, so those are the key points. If you remember those 5 points, you'll be able to draw a sine graph. Okay, flip over to the next page, and we're going to do now a cosine graph. So I'm going to move this down so I have a little more room to write, because you guys have a little more margin space than I do on my paper. Okay. And I think we'll stop here and we'll make a new video for the cosine graph.